Hello, this is the module 2 investigation 4. So previous the recording was not clean, so I'm doing it again. All right, so number 1, the perimeter P is a square. Measured in inches is expanding in size at a constant rate of change of the 4 inches per inch with respect to the squared side of the length side. So when you have a square, oh sorry, this is square, right? What am I talking about? So when you have a square, so there's a four sides, which is the perimeter is always a 4 times the side. So if the length of the side of the square change from the 0 to 2.5 inches, okay, so this side is actually changed from the 0 to the 2.5 inches. How does the square perimeter change? So as you notice, to compare to the perimeter to the side, the perimeter is always 4 times the larger than the side. So you just need to multiply, okay? 4 to the, so when the side was 0 inches, in order to get a perimeter, then you got a 4 times of side, which is going to be the perimeter is 0 inches. And then when the side is 2.5 inches, the perimeter always 4 times of side. It becomes it's always the 10 inches in here. So now what about 1, 2, 3? So now side is 1. How's the perimeter do? The 4 times of side, which is a 4. And then when the side is 3, when side is 3, perimeter always 4 times of the side. And it becomes 12 inches. So expression in the change in square perimeter of P in terms of the change in the square of the side of length is what about change of the perimeter? And that is always a 4 times of the change in side. So write a formula, construct the graph of the represent the perimeter of the square P in terms of the square side of the S, which is I want to put the side here of the square, and then perimeter is on the vertical. So if I do that, if I put it as there's a 1, 2, 3, 4, 5, and then same as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so which means we're gonna write a formula which is gonna be perimeter is always 4 times of S. So with the size of 0, of course, is 0, but 1 becomes 1, 2, 3, 4. 1, 2, 3, 4. And then size of 2 is 8, so 4, 5, 6, 7, 8 right here, okay? Yeah, so this is kind of the line that we're going to get. Okay? And then the D, illustrate the solution 12 equal to 4s, which is on the graph what this solution represents, which is now the perimeter equal to 4s, but the perimeter is 12 is a given. Now you're looking for the side of the square. So divide by 4, s equal to 3 inches. So that time, the side is going to be the 3 inches. So this time, it's 12 right here. And then when you go down to the side, it gives us the 3 here. Okay. And then E, if the P equal to 4s, s represents the square of the perimeter in terms of the square side length, the write a formula represent the perimeter of the side length s in terms of the perimeter. So perimeter is equal to 4s. So this is actually the perimeter is the in terms of the side. But now you can write the formula that is solving for s. So when you divide by 4, p over 4 equal to s, which means side is the in terms of the perimeter. Okay. And then the F, how is the formula you determine part E to relate to the formula P equal to 4S. So S equal to, so this is the same actually, but the part F, P equal to 4S is going to be the, we're looking for P using the side, and then the E, we are looking for side using the perimeter. So G, represent the change in U computing the part A as a vector of the axis. Okay, what does the length each vector represents? So vector means, okay, so from the 1 inches increases, okay, let me put the red, and then the 4 perimeter increases. And then if you put the 2 inches increases, it actually changed the 8 inches of the perimeter change. So what does the length of each vector represent? The length of each vector represents an amount of change in the value of a quantity as the quantity's value increases from some initial value to a final value. And then number 3, one must be true about the endpoints of the vector. So the starting point of the vector must be big with the initial or starting value of the corresponding quantity, and then should it be and then the ending point of the vector must end at the final value. Of the corresponding quantity. So which is a vector direction should indicate the direction of the change from the one value to the other. Okay. All right, let's go to the proportional relationship because this investigation should talk about the constant rate of the change and proportionality. So proportional relationship, which is if the one of the thing that increasing as a proportional, we can use the proportional relationship. So number 2 actually that explains well for the proportionality. All right, here are the two cylinders, one wide, one narrow. Both cylinders have the equal spaced marks for the measurement. So whatever measurement you see as a bar here is going to be same. But of course, they represent different amount though because one is a wider and the other is a narrower. So water is poured into the wider cylinder up to the 4 marks. So in here. And then this water, if you pour into the narrow one, it marks to the 6. So up to the 4, up to the 6 in here. Okay, it's the same amount of water. So if you're just looking at the mark number for the wider and narrow one, and then the ratio is going to be 4/6. Which is the same as 2/3. That's a ratio of the Mach number from the wider cylinder and the narrower cylinder. Now A, both cylinders are emptied and the water is poured into the narrow cylinder up to 11 marks. How high would it narrow rise if it were poured into the empty wider cylinder? So the ratio is going to be 2/3. And then the water poured into the narrow cylinder marks on the 11. Now they're asking for the how much will be on the wider. So you put the x, and then when you have a proportionality, you can always the cross multiply. And then you get the product of 3x equal to always 2 times 11, 22. And then if you divide by 3, and then you get the x equal to 22/3. marks. Okay, so which means 7 and 1/3 mark. Okay, so it doesn't matter which one you put. All right, and the B, okay, imagine the pour water in the narrow cylinder and next represent the varying mark number in the water, which is the narrow cylinder. As you pour, let Y represent the mark number the water would reach if you pour the same volume of the water into the wider cylinder. So what does the meaning of y over x equal to 2/3? So this is the equation. So this represents the means that the ratio of the Mach numbers that the same volume of water would be reached in the wide cylinder to the Mach number this water reaches in the, I don't have enough space, narrower cylinder 2 is 2 to 3. Okay, so this is the equation, the ratio of the Mach number. And then number 2, what does the meaning of the y equal to 2/3 of x? This is also the equation, but the volume, no, sorry, it's going to be Mach number. What am I talking about? So the Mach number in the wider cylinder is 2/3 larger than the Mach number in the narrow cylinder. That's what it is, okay? And then number 3, since we have a delta, so this is actually the change in Mach number. Is also the 2/3 times 2/3 times as large as the Mach number, which is a change in Mach number in the narrow cylinder. Okay, so when x equal to 1, what is the value of y? So we are using the 2/3 of x. So plug it in 1, you got the 2/3 for the y. And then you're using the x equal to 3. So 2/3 times 3, which is 2. And then x equal to 4.5, which is y equal to 3. 2/3 times 4.5 give you the 3. And then plot those are 3 points. So when x equal to 1. So let me put can I have a 1 as before? So 1 and 2 and 3 and 4. As x is a narrow cylinder, Mach number in narrower cylinder. And then this is also the Mach number in the wider cylinder. So wider cylinder, let's say everything is a 4 too. So every 4, so 1, 2, 3, 4, 1. 1, 2, 3, 4, 1, and 1, 2, 3, 4, 1, okay? So if I do that, okay, so when x equal to the 1, and then y was a 2/3, so 2/3, so which is, this is about here, okay? And then the x equal to 3 is becomes the 2, very nice. And the x equal to 4.5 about here equal to 3. Right? And then this actually makes a nice of the linear lines, okay? Which is if you use the the increase like that, okay? So the volume of the not the volume, some keep saying that. Mach number in the wider cylinder always 2/3 times of the narrow cylinder, which means narrower cylinder is a 3/2 times as large as the wider cylinder too. Okay, all right, so that's actually what it is. So if you go to the E for the next page, the value of the x increases from the 0 to 3. So delta x as actually the 3. What is the corresponding to the value of the delta y? So delta y was 2/3 times of delta x, isn't it? So the delta y is going to be 2/3 times delta x, which is a 3. So it's going to be a 2. So change in y also becomes a 2. Mark the 2 marks. In number 2, what is the value of the y x equal to 3? So now we have to use the 2/3 x equation. So which is y equal to 2/3 times of 3. And then it becomes a 2, which is that is the coordinates you can get, which is the 3 and 2 from the 0 to 0. And the f, as the volume of x increases, changing from the 3 to 6, what is the value of the delta y? So which is the delta y is going to be 2/3 of delta x. So from the 3 to 6, which is delta x equal to 3. So if you plug it in, so delta y is 2/3, and change in x is 3, and then it becomes a 2. So this is how much it's been changing. So compared to the contrast of what is conveyed by the three statements as a y equal to x equal to 2/3, y equal to 2/3 of the x, and then delta y equal to 2/3 of the delta x. So the first one I will explain. It's about the ratio of the marks from the larger cylinder, the wider cylinder and the narrow cylinder. And the second one is about the Mach number to find for the wider cylinder. That is always 2/3 times of the Mach number in the narrow cylinder. And then the third one is talk about changing of the Mach number in the wider cylinder always becomes 2/3 times of the change in the narrow cylinder. Okay, and then that's all for the number 2. Now, number 3, the length of the burning candle L decreases at a constant rate of 2.2 inches per hour. When the candle has burning for 3.5 hours, it is 8.3 inches long. These co-occurring values are represented by the point 3.5 and 8.3 on the graph. So we already had that here. Okay, they're talking about this. Okay, and then A, represent the increase in the time spent burning of 2 hours as a vector from the given point on the graph. What is the value of the delta L with the time spent burning increases by 2 hours from the t equal to 3.5. So we are looking for, so let me think about actually what happened for the decreases constant rate of the 2.2 inches per hour. So constant rate here, which is going to be, I want to decrease means a negative, and then 2.2 by the time. So the A, has been 2 hours. So the change has been 2 hours. So this is, I can say I can put it this way actually. So let me, instead of this one, I can write the full the formula. So which is delta y is, which is delta L. That is a better way to write it. So delta L is always negative 2.2 times by delta T. So the time change in 2 hours, so delta L, which is negative 2.2, and then the two hours passing, so it's been 4.4, the inches of the candle been decreased. And then B, this is a decrease, okay? So B represent the change in the length of the candle delta L that you found at B in the part B and as a vector from the given points on the graph. Okay, so it's been 2 hours of the passing. So from the 3.5, 2 hour previous should be the 5.5. Okay, so about here, isn't it? So 2 hours of passing, which is 2 hours. And then it decreases actually the 4.4 inches decreases. Okay, so this is going to be about 1, 2, 3, 4, and then 0.4. So about here. So negative 4.4 actually decreasing. So this is a place of the size of the candle right now. Okay. All right, let's look it up the C. Now, the decrease in time to spend the burning of the 1.8 hours, that means delta T is now negative 1.8. So in order to get a delta L, right? Okay, so as a vector from the given point on the graph. Okay, so we are putting in delta here. So let me look at the user red, okay? So 1.8 hours, the going back to the past. So if you're going back to the 1.8 hours, so which is it's about the 1.75. So you're passing to the 1.8 hours to pass, and then with a negative, of course, right? And then how much of the change is as the length of the candle? Okay, so it's gonna be 1.8 times actually the 2.2. So it actually increased to 3.96. Okay, so from here, I'm going to the 3.96. So 3.96, which is about passing the 12 and about here. So if I multiply negative 1.8 times, which is right here, negative 1.8, oh, sorry, what am I doing? It's going to be L. So delta L right now is negative 1.5 times negative 2.2, which is the other ways. Yeah, that's a better way. Negative 2.2 times time is a negative 1.8, which becomes 3.96 backed. So 3.96. Okay. So now define the formula. So C I was actually representing as right here. And then E, define the formula that relates the change in length of the candle delta L in terms of the change the number of the hours. So I can create, yeah, I already made the formula though, right? So delta L is always negative 2.2 times delta T. So after what was the original length of the candle before it starting burning here, okay? So if you want to get to the original size, actually you can start from anywhere. So you can start from this point or you can start from this point, okay? So but let me use the point that we had to put it right here. So if you spend if you go back to the 3.5 hours, right? 3.5 hours. So this is actually the negative 3.5. And then the change in 2.2 from the spending negative 3.5. And then they'll go back to the original, that means 0 hour, right? So 2.2 times 3.5 becomes 7.7. So change in the length of the candle becomes 7.7. So 7.7 is about the 16. So this is a 7.7. So this is represent the 7.7, but we know that this length from the 0 is 8.3. Right? So if you answer for G, on the axis in the part A, complete the graph of the represented length of the candle L in the terms of the number of the hours spending burning T. Discuss the graph of the... Oh, hold on a second. What am I saying? The original length. I should say the F here. So original length is going to be the 7.7 adding to the 8.3, which becomes 16 inches. So in the G, on the axis of part A, complete the graph of the represent the length of the candle L in the terms of the number of the hours spent the hour burning T, discussed in the groups as a class and how the T, L, delta T, delta L represent on the graphs. So delta, the T is going to be the time, L is going to be the length of the candle, and the delta T is a change in time, and then the delta L is a change in the length of the candle. All right, and then let's go number 5, which is I make the 2 video, but I'm gonna make a 1 video for this time. So number 5, Ellen and Elisa are attempting to find each other in crowded mall. They finally spot each other near the food court, at which point they are the 140 feet apart. They begin walking toward each other. Ellen travels at a constant rate of the 5 feet per second, and Elisa travels a constant rate of the 4 feet per second. So what quantities are varying in this context? What quantities are constants? So the varying quantity is going to be the, first of all, the distance, which we have to put the measuring units, which is a feet. And Ellen has trouble. And also, it'll be distance in feet that Elisa has trouble. And also distance in feet between the Ellen and Elisa. Okay, after they spot each other. Okay, so there's a more, I can write it on. Okay, then what will be the constant quantity? So constant quantity, of course, they already said the constant quantity as a rate. So they have a constant rate of the walking, right? So it's going to be the speed, which is in feet per hour. Oh, second, sorry. That the Ellen is traveling or walking. And then also the speed in the feet per second, Lisa is walking. And then, of course, the distance between the Ellen and Lisa when they spot each other, which is they were the 140 feet apart. Okay, so there are more steps you can write on the part A. And the part B, we already have a number of the seconds given. Then we try to find the distance. So in order to find the distance is always equal to RT. So distance for the Ellen walk is actually the rate is for the Ellen is 5, so 5t. And then for the Lisa is gonna be the 4t. And then we are looking for also distance between the Ellen and Elisa, which means distance is going to be the 140. And then whatever distance the Ellen walk and the Elisa walk, we have to subtract. So it becomes 140 minus 90. So when you plug it in, you get the 5, 10, 20, 40, and 50 for the Ellen. Elisa is a 4, 8, 16, 32, and 40. And then plug it in T as those a number, you get the 131, 122, 104, 68 and 50. So they are get closer and closer. And then for C, for each second that passes since Ellen and Lisa spot each other, how many feet closer are Ellen and Lisa? So actually, every second, they are getting closer by 9 feet, right? And then D, define the formula to relate to each of the following quantity. Be sure that it's clear to define the variable you use, okay? So Ellen's distance, I already said that 5t, and then the Elisa distance is a 4t. This between them is distance is 140 minus 4t plus 5t, which is become 140 minus 9t. So you can put it either way. And then E is, now they're asking for the how many second takes when they are actually meet each other. So when they meet each other means this is a 0 between them. So 140 minus 9t. And then so for t, you get the 140 over 9 second. But it's about 15.56 seconds. Okay. All right. And then number 6. Now we're going to talk about the different type of the distance between the two things. Okay. So this time is Taurus and Hare are competing in a 1600-meter race. The arrogant Hare decide to let the Taurus have a 950-meter head start. And when the starting gun is fired, the Hare begins running a constant speed of 9.5 meters per second. And Taurus begin to crawling at the constant rate of speed of the 4 meter per second. So illustrate the situation with the diagram, then define the formula to determine the varying distance between the Taurus and Hare in terms of the number of the second since the start gun was fired. Be sure to define your variable before trying to write the formula. Okay, so which is, all right, so this is actually the track for these two guys competing each other. So which is one side is so let's say there's a 2 lane. So one lane actually the Taurus gonna run, and then the other lane Hare goes to run. So there's a Hare over here, and the Taurus is here. And then the total range they're gonna run is 100. I think I make it too big. Okay. Okay, so I'm making it here. So here so this is where the Taurus run, and this is where the Hares run. Okay. So the total distance they run is 1600. So, but Taurus is slow, everybody know, right? So the Hare said that, oh, okay, Taurus, you can just start it right now. And then I'm not going to run until you get to the 950. So Taurus already been gone to 950. And then he only need to run for 650. So this is the Taurus has to run. And the Hare is going to run all the way through the 1600. So but we are looking for the distance between them, okay? So that's what we think. So let's say, and then now the Taurus is ready to run from here. He's here. And then the Hare is right here. And they are warming up to get ready to run. So let's say, and then the gun was fired. And then they're here. So, but the actual distance we're looking for is from here to here. Oh, no, here. Sorry about that. So for the hair, yep. So actual distance that we are looking for is this distance. Okay, so whatever distance between them. So So Taurus distance is actually the 650 minus 40 to be this. And then the Hare to distance is 1600 minus 90. But we are looking for distance between the Taurus and Hare. So what we need to do is we're going to subtract from the Taurus distance to the Hare's distance. Hare's distance to Taurus distance. Sorry about that. So 1600 minus 90 and subtract up 650 minus 40. So if you simplify 1600 minus 90 minus 650, and plus 4t. So actual formula is going to be 950 minus 5t. So this is always stays the same as distance between the torus and the hare. Okay, so that's actually that I can do as a problem. And then B, construct a graph that represents the varying distance between the torus and hare in terms of the number of the seconds since the gun start. So this is actually the time as in second, and this is distance in the meter. Okay, so if you graph this, we are graphing the 950 minus 5t. So on the horizontal axis, each of the okay, let me use another colors. So each of the intervals I use as a 20. So 20, 40, 60. So maybe I want to put the 40, 60, 80, and 100, 140, 160. Okay. Oh, 200. 2, 4, 100. What am I doing? I don't know how to do this. Okay, sorry about that. All right, let me do it again. So I'm gonna use a different color. So on the vertical axis, I wanna put the each one is so 20, so 40. Okay, so 1, 2, 3, yeah, 40, 40, 80, and what's a better way to do it? Okay, let me think about it. So let me see which one is better. So 20, because they have to all the way to the time as okay, I think I can put it as 20, 40, 60, 80, 100, 120, 140. Okay, all right. So everything is just a 20, okay? So 20, 40, 60, 80, 100, 120, 140, 160. Okay, I think that'll be enough. And on the other side, I want to make the each one is a 50. So, and then 100, 200, 300, 400, 500, 600, 700, 800, and 900, because they're starting from the 950, okay? So 950 is about here. And then the ones, actually, let's see how many seconds, okay? So if I just use any of the, so 1 second is not that important, right? So can I just say 80 seconds? So 950 minus 5 times 80 seconds, and then becomes 550. So 80 seconds, about 550 right here. Okay. And then what about the 160 seconds? So 950 minus 5 times 160 second, I still have a 150. So 60 has 150 right here. So if I put it as a line through this, this actually end up to like this. Okay. All right. So C, who finished the race first, the tortoise or hare? How long does it take each animal to complete the race? All right. So in order to find that, so we can find this way though. So first of all, the tortoise distance was 650 minus 40. So complete the race means the zero distance from there, right? So distance for the tortoise takes 162.5 second. For the hare distance is 1600 minus 90, which is the 0 equal to 1600 minus 90. So for t, and becomes 168.421 second. So as you noticed, oh, torus won. Because the torus takes the less hours to complete the 600 feet, right? Okay. All right, number 7. At a 7 inches candle is lit and burns a constant rate of the 1.8 inches per hour. Let T represent the number of the hours since the candle starting the burning. So this time was changing length of the candle is going to be negative 1.8 T, right? The delta T. So what does the expression 1.8 T represent this context? So 1.8 T means that's the length of the candle. The length of candle that has been burned. Okay, and then what does the 17 represent? Okay, that was the original size of the candle. Or initial, the length of candle. And see, what is the 17 minus 1.8 T? That is the length of candle. That's the length of the remaining candle. And then what is the 1.8 represent? That is the constant rate of change of the candle length with respect to the number of the hour. And then what is L equal to, what is the formula L equal to 17 minus 1.8 T? What does L represent? So L is exactly represented represented by the 17 minus 1.8 T, which is the same as C, right? So this is actually the length of the remaining candle. Alrighty, so that's all for the investigation 2 and module 2 and investigation 4. Thank you.